All right, in this lesson we're going to be solving absolute value equations and also graphing them. It's important that you understand what absolute value is actually indicating. Absolute value is a number's distance from zero. A lot of times students just think absolute value is just the positive of whatever is inside the absolute value bar, the absolute value bars. However, the reason why it's always positive is because it represents a distance. There's no such thing as having a negative distance. So if we look at a number line, if we look at the numbers 2 and negative 2, both of those have a distance from 0 of 2. So the absolute value of 2 would be 2, and the absolute value of negative 2 would also be 2. So the absolute value of negative 2 is the same thing as the absolute value of 2, which is 2. Both of those numbers, negative 2 and 2, are 2 units from 0. Now, the quantity inside of the absolute value bars, it always, for the reasons stated on the previous slide, it always takes on a negative and also a positive value. For example, the absolute value of x equals 3. If we were to read that sentence, it says that the distance, if the x's distance from 0 is 3, then what is x's value? And there's two numbers on the number line that have a distance from 0 of 3. One of them is positive 3, and the other one is negative 3. If we had something like this, if we read that sentence, it would say, what value of x is negative 4 units away from 0? And you cannot have a negative distance, so it doesn't make any sense. This suggests that there's a negative distance, which is not possible. All right, example 1. We've got the absolute value of 7 plus 7n plus 7 equals 28. First thing you want to do is isolate the absolute value bars. We're going to isolate the absolute value bars by subtracting 7 from both sides. When we do that, we get the absolute value of 7 plus 7n equals 21. Now we're going to set up two different equations. One where the quantity inside the absolute value bars is positive, and another where the quantity inside the absolute value bars is negative. So we're going to start with the positive quantity inside the absolute value bars. We'd have 7 plus 7n equals 21. Subtract 7 from both sides. Get 7n equals 14. Divide both sides by 7. N equals 2. For the negative quantity inside the absolute value bars, you can either distribute the negative, or you can go ahead and just divide both sides by the negative 1. I prefer to divide both sides by the negative to get rid of the negative from the start. So if I divide both sides by negative 1, I get 7 plus 7n equals negative 21, and then solve the rest of that equation. Subtract 7 from both sides. We get 7n equals negative 28. Divide both sides by 7. N equals negative 4. So we have two solutions, two possible values for n. N could either be 2 or negative 4. Whenever you're writing your answer for the two solutions, separate them with a comma and put the smaller solution first. So that would be written like this: negative 4, comma 2. Next example, again, we want to isolate the absolute value bars by subtracting 10 from both sides. That'll give us negative absolute value of 6v plus 1 equals negative 1. And then we want to divide both sides by negative 1 because we want positive absolute value bars. So that'll give us positive, the absolute value of 6v plus 1 equals positive 1. And then I'm going to write out the two equations. One equation should have a positive value quantity for what's inside the absolute value bars, and the other one should have a negative quantity for what's inside the absolute value bars. We're going to work with the positive one first. So we subtract 1 from both sides. Get 6v equals 0. Divide by 6. V equals 0. So that's one of our solutions. And then for the negative quantity inside the absolute value bars, I'm going to start by dividing both sides by -1. It's going to give me 6v plus 1 equals -1. Subtract 1 from both sides. 6v equals -2. Divide both sides by 6. V equals -1/3. So again, put your smaller solution first, comma, bigger solution. Next, again, isolate the absolute value bars by subtracting 3 from both sides. That gives us the absolute value of 3 plus 5m equals -27. And you should notice that there's a problem here because we have an absolute value equal to a negative number, which is not possible. That statement suggests that quantity inside the absolute value bars is a negative distance from 0, and you cannot have a negative distance from 0, can't have a negative distance period. So our solution is no solution. All right, next example. Now we have absolute value inequalities. We're going to carry out the same steps. So we want to isolate the absolute value bars by dividing both sides by -4. When we do that, we get the absolute value of 6 minus n is greater than 11. Remember, if you divide or multiply both sides of an inequality by a negative number, you have to change the direction of the inequality. All right, so it was initially less than, now it's greater than because we divided by -4. And you still have two separate inequalities, one where there's a positive quantity inside the absolute value bars, and one where there's a negative quantity inside the absolute value bars. Starting with the positive, subtract 6 from both sides, we get -n is greater than 5. Divide both sides by -1, which is going to change the direction of the inequality again. We get n is less than -5. And then for the negative quantity inside the absolute value bars, we're going to start by dividing both sides by -1, which is going to change the direction of the inequality. We get 6 minus n is less than -11. Subtract 6 from both sides. We get -n is less than -17. Divide both sides by -1, which is going to change the direction of the inequality again. We get n is greater than 17. So first thing you want to do is graph it. All right, so there's no bar under either inequality, so we should have open circles at -5 and at 17. Starting with the inequality on the left, the arrow is pointing to the left, so our arrow should be pointing to the left also. For n is greater than 17, open circle at 17, arrow's pointing to the right, so our arrow should be pointing to the right also. And you want to write the solution using interval notation. All right, so once we have the graph drawn, it's a lot easier to write the interval that contains our solution. So as you can see, the left arrows on the graph, that goes to -infinity. So anytime you have infinity, you want to start with a parenthesis. Parentheses should always be next to infinity, since infinity is not a finite number. All right, so -infinity to -5, and then there's an open circle at -5, so it should be a parenthesis next to -5. And then for or compound inequalities, you should have a union symbol in between the two intervals. All right, so union, and then there's an open circle at 17, so parenthesis 17, and that goes to positive infinity. And there's always a parenthesis next to infinity. Last example, we want to isolate the absolute value bars by adding 8 to both sides. When we do that, we get negative absolute value of 5 minus 9v is greater than or equal to -5. And we divide both sides by -1 to get rid of that negative in front of the absolute value bars. That gives us absolute value of 5 minus 9v is less than or equal to 5. Again, the direction of the inequality changed. We flipped the direction of the inequality because we divided by a negative number. Write out the two inequalities, one that has a positive quantity of what's inside the absolute value bars, the other that has a negative quantity of what's inside the absolute value bars. Subtract 5 from both sides. Get negative 9v is less than or equal to 0. Divide both sides by negative 9, which is going to change the direction of the inequality. We'll get v is greater than or equal to 0. And then on the other inequality, I want to start by dividing both sides by negative 1 to get rid of that negative in front of the parenthesis. That gives me 5 minus 9v is greater than or equal to negative 5. Again, the direction of the inequality changed because we divided by negative 1. Subtract 5 from both sides. We get negative 9v is greater than or equal to negative 10. Divide both sides by negative 9, which is going to change the direction of the inequality again. V is less than or equal to, a negative divided by a negative is a positive. So start by graphing the solution. So for the both inequalities, we have bars up under the inequality, so we should be graphing closed circles. For the inequality on the left, V is, the arrow is pointing to the right, so we're going to have an arrow to the right from 0. And then for V is less than or equal to 10 over 9, again, we should have a closed circle, and that arrow is going to be pointing to the left. For and compound inequalities, we're looking for the intersection of those two graphs. So the intersection of those two graphs would be that space in between 0 and 10 over 9, including 0 and 10 over 9. So if we were to write that using interval notation, we should have a square bracket because it's a closed circle at 0, and that goes to 10 over 9, and there's a closed circle at 10 over 9, so there should be another closed bracket after 10 over 9.